If I told you the scary looking graph can be written with two formulas, would you believe it? Let me explain. In discrete time, a unit step is at value 1 when n is greater than or equal to 0, and 0 everywhere else. You might be wondering how this can be represented mathematically. The trick is to use a unit impulse, or other known as a unit sample. Just like a unit step, a unit impulse is 0 everywhere where n is less than 0, only now so after 0 as well. So if we could somehow stagger these delta functions one after the other for each index beyond 0, we should get a unit step. So mathematically that would look like u of n, with u just being a conventional term to describe a unit step, and the bracket n is to describe any discrete index in time we are interested in, is equal to the summation of one unit sample, one unit impulse, delayed by one index at each discrete unit of time. That's it. Here, the k is an integer and represents how many indexes to the right our impulse spike is located. And the limits of the summation start from k is equal to 0 when the impulse spike is at time n is equal to 0. That corresponds to this right here, up to infinity. A unit step remains at value 1 forever after n is greater than 0. You now have the first formula. Now the second formula is counterintuitive. For a second, I want you to imagine or take a look at this unit sample. If I were to add every value of every index when n is before 0, that is from n is less than 0 to minus infinity. If I were to add every single value of that unit sample, I would get 0, because the delta spike does not occur until n is equal to 0. So I could add every value from minus infinity up to, let's say, minus 1, and it would still be 0. The moment I cross that threshold, when I include n is equal to 0, we are now introducing the spike. And so the summation from minus infinity up to 0 would be now equal to 1. The important part here is that I can now do the same beyond 0 for n is greater than 0, where I can add every value from minus infinity up to some positive number, n, some positive integer, and the answer would still be 1, because there is only one delta spike corresponding to a value of 1, and that is at the center when n is equal to 1. N is equal to 0. So now again on the left is u of n, and that is equal to the summation of a unit impulse centered at k is equal to 0. No delay this time. K is just a constant. However, our lower limit for the summation now starts at minus infinity rather than 0, and is summed up to n, the particular index we have interest in. This gives us the exact same unit step that stretches to infinity across time. And so picking a value of n was arbitrary. It only allowed us to see what value our step function was at that specific index. If n was a negative integer, say -5, u of -5 would be 0. If we pick n to be 0, we see that u of 0 is equal to 1. And that's because we're now starting to include the positive one included at the delta spike when n is equal to 0. And here's the best part. If we pick n to be any positive integer, whether it's 1, 10, a million, or infinity, the value of that unit step at that index would also be just 1. So now you know the two formulas to describe a discrete time unit step.